and now we know about more about singly, doubly, and circular linked list, and like how to create operation in the linked list. So I already talked about the detail, like a linked list is like a train where each bogie is connected with the link. Different types of the linked list exist in the make life easier, like a image viewer, music player, or when you navigate through the web pages. So they are all like a linked list so they are all the linked list in the data structure. So what are the types of the linked list? So there are the singly, doubly, circular, doubly. There are the various type, three the four key types, but here we are going to talk about only singly linked list, doubly, and circular linked list. So what is singly linked list? So singly linked list is a, you see this image and keep in your mind, because very important is starting, then head you have the two element here, 200 and 3 104 100 5 100 over it, and then 7 and a singly linked list is a unidirectional. So singly linked list is unidirectional. So unidirectional means this direction is unidirectional, and bidirectional means provide the both side direction, and unidirectional means one side direction. So singly linked is, these are the linked with the unidirectional linked list. So you can only traverse it the one direction from head node to tail node. So the singly linked list is only going to be from the head node to tail node. Now structure of the singly linked list. So there are the many application for singly linked list. One common application is to store a list of the item that need to proceed in order. For example, singly linked list can be used to store a list of the task to be need to completed with the head node to the lastly tail node, representing the last task to the completed. Singly node list are the also often used for the algorithm that need to process a list of the item in the reverse order. For example, popular sorting algorithm quick sort uses a single linked list as a processing the list of the reverse order. Quick sort can sort the list more efficiency. Now creation and traversal singly linked list is a data structure that store the sequence, the element. Each element is a list is called a node, and each node has the next node at the list. The first node is a list called head, and the last node is called the tail. To create a singly linked list, we first need to create a node class. Each node will have two data members, an integer value and the reference to the next node in the list. Next, we need to create the linked list class. This class will have two data members, a head node and a tail node. A head node will store the first element in the list, and the tail node will store the last element in the list. To add an element in the list, we need to create a new node and set up the next reference to the previous tail node as a point to new node. Then we can set the new node as a tail to the list. Now to remove an element from the list, you have to need to find the node that contain the value the want to remove. We can do this by traversing the list until we find the node with the matching value. Once we find the node, we need to set the next reference in the previous node to point the next node. To search the element in the list, we need to traverse the list until we find the node with the matching value. So now understand what is the doubly linked list. A doubly linked list is a bidirectional linked list, so we can traverse in the both directions. So here you can see doubly linked list in the both direction. Unlike singly linked list, its node contain one extra pointer called the previous pointer. This pointer points to the previous node. And structure of the doubly linked list, you can recall in your mind. This is this diagram, so understand for better. Structure of doubly linked. So doubly linked is a singly linked list is a data type structure that consists of the same set of the linked. So it has the singly linked list, each of which doubly linked. It is used to store the data in the way they allow for the fast insertion and deletion of element. Now last one is a circular linked list. Circular linked list is a unidirectional linked list, so we can, this is unidirectional linked list, so we can traverse it in the only one direction. But This type of the linked list has it at least last node pointing to the head node. So with traversing, you need to careful and stop traversing when you revisit the head node.